thank everyone for attending the call. My name is Keith Finnerty. I'm a lead data scientist within the newly renamed Cloud and Innovation Network and Engineering in TDI and Deutsche Bank. And today I hope to bring you through a brief presentation that outlines AI and the transformative role that we believe it'll play in the future of banking and financial services. To realize the benefit of AI, we really need to address all of the kind of the new risks that come with AI applications and services, and to overcome a lot of the restrictions that are currently in place to build out AI products within financial services. We will also need to continue to enable our staff as well to become a little bit more AI literate, as we are now taking AI out of the labs and bringing it into production environments. They will now be interfacing with it on a daily basis in their working environments. As way of introduction, this topic presents an overview of some of the challenges that we'll face and highlights common problems within the bank and that are now addressing AI risk and building towards AI literate workforce. First of all, I'd like to give a brief introduction of myself and my group. So my name is Keith Finnerty, as I said. I am a lead data scientist within Cloud and Innovation Networking. A sub-team within that is AI engineering, and we are a center of excellence for analytics and data science within Deutsche Bank. We recently partnered with Google, and we're looking to bring not only our innovation projects into the cloud, but also current applications within the bank into the cloud. We're currently working on it at the moment, and we will continue to work on it into 2022. I suppose our group then works on machine learning problems, big data problems, on a kind of a wide array of functions across the bank, from revenue generating to risk mitigation, AFC, etc. So with that context then, I'd like to introduce what is AI and what role will it play in the next generation of banking. So a very kind of brief definition of AI, we can think of it as a system that experiences their environment through data and transforms that data to kind of work towards an agreed upon goal or to complete a task. We could think of self-driving cars in this respect. A movie recommendation engine is something we're all probably a little bit more familiar with, and one that's kind of quite close to what we want to work on is identifying likely fraud within transactions. As a scientific discipline, then we can kind of divide AI into like 4 key areas. So we have analytics and advanced analytics, and this is really to provide insight and recommendations to business stakeholders so they can take action upon learned behaviors and insights within the data. There's the interactive element as well, which is kind of communication through either chatbots or personal assistants. And this is really to kind of allow business users to more readily interact with AI systems where applicable. We have visual systems then as well, and they're looking to really interpret and extract information from visual medias such as pictures and videos, and to perform either inference or classification or detection on top of that. And the final one then, and kind of quite important one within our area as well, is text. And it's really looking to, I suppose, process, understand, and extract information from text, and in some cases then as well to generate natural language responses, which is really important. In many ways, the bank is entirely being transformed by big data, AI and ML technologies. A recent survey by McKinsey found that 47% of banking executives thought that AI was going to have the greatest potential to impact their organization when compared to other disruptive technologies. Because of the pace of the research within the AI realm, things are moving really, really fast. It's important to stay ahead of the game. But at the same time, we need to balance that with a little bit of a kind of a sense of the risks that poses. Any negative consequences due to the desire to kind of leverage AI can have serious consequences for large organizations and in particular banks. So I've collated some of the key areas in which AI can lend itself to across the bank, such as capital markets, deposits, lendings, payments, investment managements. Across all of these use cases, we'll see AI readily used in the back office to automate and to improve efficiencies. But there's some more specific advantages we can also kind of extract here. Within capital markets, we're like to see opportunities to use advanced analytics to match investors to the capital market investments they're more suited to. This could be disruptive for very large players in the game, as it reduces the defensible advantage with the best connected firms and give opportunity to less advanced firms in that area. In the area of investment management, we'll also see advanced analytics expanding across the area of wealth advisory services, and really means that that will no longer just be the provides of the wealthy. It also means our services can become more personalized. With the ability to analyze large amounts of data, we'll be able to tailor products and services to people in a more personalized way. So current AI can be thought of as being very narrow. In many cases, it's essentially trying to optimize for a single problem. So if we're thinking of a ball rolling down a hill, it's trying to find the deepest valley in a kind of a large multidimensional space. This means they're very good at very specific tasks, often experts in tasks, but they're not good at solving general problems. Some of the best performing AI algorithms are deep neural networks. They can be thought of in a lot of cases as being black boxes, which means we don't really have great insight into how they're coming up with their observations or their predictions. The combination of narrowness and lack of explainability can give rise to certain weaknesses within the algorithms themselves. Two main areas of concern in production AI solutions are kind of illustrated here. So with adversarial attacks, we're essentially trying to augment the image in a perceptible or non-perceptible way to modify the outcome of the AI algorithm. In the first image here, we can see the algorithm correctly classifies the exact type, indeed, of apple in the picture. However, by simply placing a card in front of it with the word iPod, we get a very different classification with a very high degree of certainty. And that kind of demonstrates the weakness in this particular system. We also have to take great care in terms of the bias or the gaps that might be within the data itself, particularly when we're training models on it for the first time. An example illustrated here is the husky classification problem. We're looking to detect whether an image of the animal is a dog or a wolf. Through discrimination and kind of looking at what's really driving the underlying algorithm, we can see here it's very frequently not the animal itself that's driving the classification, but the surrounding information, the background. So we can see that while the algorithm could be very, very accurate, our data set is a little bit biased, and the algorithm is leveraging that to make more accurate predictions. So let's have a look at some of these weaknesses in practice. You can see here that while the other examples were quite trivial and they were really toy examples, algorithmic robustness is a real issue, and any sort of bias or fairness that come into it can have a real impact to the organization that deploys it. Looking here, if we look at the declining transactions can lead to a great loss in revenue, or an algorithmic error can greatly impact not only a business position, but indeed entire markets. Not accounting for bias, either gender bias within credit applications or recruitment applications can have huge reputational risk for different organizations. In summary, for applications that make it into prod or indeed are client facing, we have to be very careful and adhere to a set of guidelines. But what are the guidelines? We want to have trustworthy AI. What does that actually mean? So many governing bodies and commissions, such as European Commission, the US Department of Defense, Singapore regulators, are coming up with guidelines for ethical use of AI. Now, AI applications are still governed by existing fiduciary requirements of financial services companies set out by regulatory bodies and governing bodies. However, it's a rapidly evolving space, and that means that there's indeed increased risk at play. So the idea is to build up a trustworthy AI framework that captures some of the potential risks that may arise for data or the algorithm that you're implementing, and address them through the development process. This framework needs to be developed on top of a couple of key things. One is a common definition of AI. So what is within the remit of this framework, and what is outside it, and that needs to be agreed upon across not only the organization, but in many cases across the industry. We should have a set of agreed upon ethical principles by which we want to develop these algorithms in the future as well. And these are fundamental from which then we can take more practicable test cases from. We want development guidelines as well to make sure we adhere to key requirements, and these may be even business line specific, but they might also be organizational wide. And finally, we need to, at the outset, define an assessment criteria. So what is a successful outcome for this algorithm? But also, indeed, how do we make sure this successful outcome meets the guidelines that need to be put in place? Finally, it's important that all of this is underpinned by aligning to the legal requirements and organizational policies that are already in place. So how will this impact future work? These are just a couple of examples, but as AI is likely to remain narrow for the foreseeable future, it does mean it's going to be limited to specific tasks. This doesn't mean that AI isn't powerful. It can outperform humans on very specific tasks across multiple domains. So in the area of medical diagnosis, and in particular medical imaging, AI is being used on medical scans. It's quite good at defining kind of strategies and long-term decision making, such as chess or Go, those kind of games. It's also very, very good at identifying particular patterns or outliers and looking for that needle in the haystack, which can be assimilate for detecting suspicious transactions. And indeed, we can combine multiple narrow AIs together to perform complex tasks and to deliver meaningful business outcomes. Narrow AI, however, means that we do need a model for each solution and for every task we want to assign it for. In fact, we might need multiple models. And this means that we will need to look at AI replacing certain tasks and not jobs entirely. This will then result in, I suppose, day-to-day life and working environments being augmented by AI as automation is increased. And that then will mean that we'll spend less time on the mundane tasks, freed up to more valuable activities. And this is something that we're seeing currently, particularly for data scientists. There's a large amount of automation that has been put into data science tooling that we're already leveraging, such as AutoML, auto feature generation, and even automated model deployment and management systems. And that's really what we're looking to do in the way forward, is to make our own jobs, the data science jobs, more automated. And then knock-on consequence of that will mean that we won't need tens of thousands of data scientists building models for each specific task. And what we want to do is build up pods of data scientists and engineers, product specialists, SMEs, and to address real specific business problems. So we can get very well-defined AI solutions. We'll also need users to understand the limitations of the AI solutions that we're implementing. So as these users interact with them on a daily basis, we want them to be able to understand the limited application of AI, trust when they think there is an error, that they can override it and fail safely. So we really want to make sure that we still have the human in the loop element of this. To be successful, then organizations will really need to redesign the working process and to think a lot more task orientated, so that AI can then be used to augment and support those tasks in the future. This means we need to enable our staff to be a lot more AI literate. We need to upgrade our tools, our platforms, and we need to put in place standards for reusable blocks so we can accelerate the delivery of AI and innovation. And I think cloud platforms can play a huge role in this. So looking ahead then, what's certain is that we'll see a lot more ML and AI solutions making it into production and out of the lab. Today we're seeing the emergence of automation for large parts of the process of getting AI from dev into prod. And cloud vendors are really enabling this. You can kind of think of them, they're doing what previous experts in the field of manufacturing had done for automation, such as Toyota, Ford, Nissan, etc. With this then comes its own challenges. So as we enable the practice of getting more and more AI into production, we need to ensure that the monitoring and the controlling of these AI systems grows with it. So without the development of the tools and the frameworks to be, I suppose, more supportive to the data scientists that are putting these models into production, there's a large amount of effort that's associated with it. So we believe that potentially is the next step in the cycle to automate the full ML lifecycle, and then humans will become a little bit more in the oversight process of the ML lifecycle and be more effective in their day-to-day working efforts as data scientists. So I'd like to thank you for sticking with me this far, and then I'd like to open it up for questions.